So the best thing to do with this hurricane situation is to make sure that your emergency contact information is in the system well, and that like your phone number and everything is in there, and that you have it set to be able to text you and such. They'll call, text, email. It can get annoying, right? But it's best just so that you have all that information, okay? If anyone has any issues, you don't know where that is, I can show you after class. It should just be in my FAU in Banner, so in the self-service section where you go in to register and so on, okay? Under like personal information or something like that, okay? Any questions on anything like that? Okay, so obviously this could affect kind of our days of class and such, especially where we're supposed to have class every day of the week pretty much, right? So I will try to kind of keep you updated and such once I know information on kind of what we're doing with material and so on, okay? And make you definitely aware of, you know, when we change due dates, or if we have a revised kind of, you know, course schedule, the thing at the end of my syllabus, right? Pacing guide kind of thing. Okay, so any questions on anything there? No? We're all good? Makes sense? I will, you know, try to keep you updated. I live in this area. I ride my bike to campus, so I pretty much get the same weather as this campus does. So last year when the hurricane went through, I think it was last year, right? Year before, thank you. Yes, it seems like last year. I lost power, this whole area did, for about 5 days. So that was about the same kind of category and everything, so that could very easily happen again. Okay, who's not from this area and this is their first hurricane? Okay. It's not? Okay. Well, so if you've not been watching the news, we do not want to get the east side, right? That's the dirty side. That's when we will get the more damage, okay? So just keep yourself aware, and if those of you that are not from this area, if you choose to go out of town, let me know just so that I can know when to expect you back and such, because there's going to be a lot of people leaving the area and then having to come back, and it'll cause, you know, issues and such, delays, cancellations, and so on. All right, the best thing, you know, don't worry about this class. With this kind of thing, I will make it work. Okay, we'll work out whatever issues we have. The best thing for you is just to be safe. Okay, don't worry about college algebra or whatever. Okay, if you leave the area though, you can certainly still work on homework, right? Because you'll have power for sure. I have to say that, right? I have to. Okay, so we finished pretty much up the lecture for 7-1 on Tuesday, right? I just have one more problem that I wanted to do, and then we'll move into 1.4, right? Yeah, 1.4, quadratic equations, okay? So, just to then really quickly kind of talk about the quiz from yesterday. So with that, since it was 10 questions, right, and you could pretty much only get any of those questions completely wrong or completely right. Everybody got on, you know, even 10s in scores. So if you get, this is good for the rest of the semester, any quizzes that we take, okay? This is just on quizzes that I'm talking about at this point in time. If you got less than a 65, okay, that means you can go in to the math lab, not the MLC. This is not something that happens in the MLC where I have my office. The math lab is where we have class for our lab, okay? I will resend out their hours. I just didn't want to send them out without kind of telling you why I'm sending them out first. So you can go in there. You have to completely redo the questions that you got wrong on the quiz. If you do that, you can get a point back, meaning your quiz grade can go up 10%. However, the maximum it can go up to is a 65. Okay? So that means if you have a 60, you can do the problems you got wrong, right? And then go up to a 65. If you got a 70, well, you can certainly still go in and do the problems you got wrong. I would love for everyone to do that, obviously, because we're going to have some of those same questions on the test, right? And then going forward, it's still important information. However, you will not be able to earn a point back, okay? This is just kind of our way of enticing, you know, maybe anyone that's discouraged by a low quiz score to keep working positively towards the end goal, okay? Questions on that? Yeah, in the back.
Yeah, so you have to go to
The math lab where we have class, which I will send out hours for tonight or tomorrow. Soon. Soon. Yes. I'm sorry? That is the only way you can get a point back. You have to go in there because they have your scrap work. They keep it there for me so that it's all there where we have class and everything. So you have to then go in and completely do from scratch the problems you got wrong. Okay? Yeah?
Is all the tests online too?
Yes. Everything is in the same program so that we're not, you know, giving you some vastly different like question style or anything like that. So every assessment that we give you is all in the same place. Okay? Anything else? Any other questions? No? Make sense? Okay. So at this point, we'll go ahead and get started in on material. So, if we have 3 donuts and 4 bagels, and they cost $10, and 2 donuts and 1 bagel cost $4. What is the cost of a donut and what's the cost of a bagel? Okay, so what's the thought process here? Where should we start? What do you mean? Which smaller number? Okay, we can start there if you want. So if we have 2 donuts, 1 bagel, and they cost $4, what does that mean? Right? What are we trying to do first? What are we trying to find? We're trying to write an equation for sure. But the end goal is to find the costs of a bagel and a donut, right? So, why don't we say that D is the cost of a donut and that B is the cost of a bagel. Okay? So, if we're going to use these as kind of the meanings of our variables, so now we can set up cost equations, right? Does that make sense? Okay, so if we know things about the costs and how they relate to the amount of items sold and so on, right? We can use these variables to set that up. So that means how we want to kind of set up this style of equation is number of items, So kind of number of items times the cost of the item right? And then we repeat kind of as many variables as we have, and we set it equal to the total cost. Does that make sense? So we were told the amount of donuts, amount of bagels, and then the total cost, right? So we can set that up. We have 3 donuts, so we should say number of items times cost of item. So the cost of the item, see, we don't know it, right? Plus, then we just repeat with bagels. So we have 4B is equal to $10. Okay? So this is basically saying, right, if donuts cost $1 and bagels cost 50 cents, right, then we can plug that in, multiply by however many, and then get the total cost, right? Now obviously it's not $1.50, I just made that up. But we can figure that out. What is our next step? Get the next equation. Because we can't do nothing with this. Not yet. We have 2 variables and 1 equation, right? So remember what 7.1 was. It was systems of equations, right? So we need to write out the system. The second system is that kind of second line. So how should I write it?
2D plus 1B equals 4.
2D plus 1B equals 4. Exactly. So now, what do we want to do? So remember, we have 2 methods that we like. We don't like the third one, graphing. So we can do substitution and we can do elimination. Realistically, with this one, we could do elimination. I would not choose D to eliminate, right? 3 and 2 have nothing in common. That means you would have to change both equations, right? You have to make them both 6 or -6 kind of thing. So you have to change both equations. You could pretty easily eliminate B, right, by multiplying by -4. Or we can do substitution and solve for B. Since it has a coefficient of 1, that makes it pretty easy. What do we want to do? Substitution and then elimination. Okay, so substitution it is. So let's solve for B in this equation, right? So that means we have B is equal to -2D is equal to 4. I subtracted the 2D to the other side. Oh, wow. Never mind. Sorry. Plus 4. That's the confusion. Yes. I just like equal signs in that one. Does that make more sense now?
Yes.
Yeah. Okay, good. Yeah, I just subtracted the 2D. And then decided to write the equation incorrectly. But heck, it happens, right? As long as we catch it, that's what matters. So now, what do we do? Question?
Yeah, I'm really confused.
Okay,
If you took
that's
negative-
fine.
If you took 2 out of 2D,
I didn't take 2D out. I just moved the whole term,
You subtracted 2D from both sides.
right? I subtracted. So these cancel. And then we just have -2D plus 4. I just like writing the variables first. I don't know why. It's a weird quirk, I guess. Doesn't really matter. Okay? All right. So what now?
plug it in.
Plug it into what?
Yeah, top equation.
Top equation. Why not this one?
Okay.
It's the one we just changed. We'll get a true statement. So we plug it in here. Because of how I had to set up the recording, I can't really very easily use this side of the boards. So I'm gonna jump over here. I apologize. Trying to make it work as best I can. So we have 3D plus for b, so we plug in. We have b is equal to negative 2d plus 4 equals 10, right? And then I just wrote off of the, there. So, we now have this equation. What do? Distribute. Okay. So we have 3d plus minus. That one was on purpose. Okay. Minus 8d plus 16 equals 10. Okay. Now what?
Subtract 16 from both sides.
We could
8D and 3D.
subtract the 16 and combine. Yeah. So this gives us negative 5d. And if we subtract the 16, now you don't have to do all these steps at once, right? If it confuses you, please do it individually. Separate it out, right? However it works for you, that's what matters. So then we have 10 minus 16, so we get negative 6. Then we get d is equal to, the negatives cancel, you get 6 over 5. This type of question, because it's asking about a dollar amount, we talk about dollar amounts in 6/5? No, we talk about it in hundredths, right? In cents. So we would divide this. This is equal to $1.20. Okay? However, I would not plug $1.20 in. I would use the 6/5. Because as much as we probably don't like fractions, we mess up a little bit more often with decimals than fractions usually. Just as an overall thing. If you're good with decimals and you really don't like fractions, go for it. Have fun. I don't mind. Okay? So now what? We plug in. Why don't we, right? Go ahead and plug into this one. It's already solved for b. So b is equal to negative 2, and then d is 6/5 plus 4. Okay? So then b would equal negative 12/5. We know we want the 4 to be in 5th format, right? How do we make it in 5th format? What do we multiply by? 5? Just 5? On both ends, top and bottom. So multiplying by 1 or in form of 5/5. So then we're adding 20/5. Right? So then b would be equal to, if we add those across, 20 minus 12 is just 8/5. That is $1.60. Okay?
Okay, this is probably dumb I'm asking, but
There's no dumb question.
negative 12 over 5, how'd you get there, like the steps?
Multiply. So think about integers, right, as over 1. So then we multiply across and multiply across. So negative 2 times 6 is negative 12. And then 1 times 5 is just 5. Good? Okay.
Yeah.
How did I get 5/5 to multiply by? Because I know we wanted to have 5 in the denominator and 4 was over 1. So we had to multiply by 5 in the bottom, but we have to keep it even, so we had to multiply by 5 in the top. Anybody else? We good? So our kind of final answer here would be that donuts cost $1.20 and that bagels cost $1.60. Okay? All right, so that was it for 7.1. That's all we had left to finish, but you can see why I didn't do it on Tuesday. So, is it okay if I erase this? We good writing it down? Almost? Almost? Okay, go ahead. We good if I erase the question part? Okay. Now remember, it's in the recording too. And I'm going to attach pictures of my notes to it as well. Okay, so this next section is on the quadratic equations, and mostly on solving them. Okay, so remember, quadratic equations are of the form ax squared plus bx plus c is equal to 0, where a, b, and c are integers, and that a does not equal 0. Okay? If a equaled 0, well, that would make this whole term go away, and then we would be back down to just linear format, right? We wouldn't have a quadratic anymore. Okay? All right, so then, like I said, basically, we're just kind of looking at the different ways of solving quadratics. So if we have x squared minus 4x equals 5, kind of as our first example. The first thing we always call interrupted. Okay, so the first thing we always want to do is to make sure we get it equal to 0, right? If we factor this, we can't use what's called the kind of 0 multiplication property, right? That if we have p times q equals 0, either p equals 0, or, this is important, but it's or, q equals 0. Okay? Yeah?
Just run it, like, what does P and Q stand for?
Terms.
Oh,
Two things being multiplied.
I'm tripping, okay.
Yeah, that's okay.
I was just making sure, like,
P's and Q's, they're very just magical, and you've never seen them before? No, I'm just kidding. I'm just teasing. I'm just teasing. They're just variables, just to mean like if we had x plus 1 times x plus 2 equals 0, right? Then x plus 1 has to equal 0, or x plus 2 has to equal 0. We've all seen this property in use probably, right? This is the technical version of it, okay? We obviously certainly don't have to use this version ever. It's just saying out two things being multiplied equals 0. One of them has to be 0. It's the only way it works. We just don't know which one. So we say both. Okay, so we get it equal to 0. So we have x squared minus 4x minus 5 equals 0. Right? And now we're back into kind of what we had a bit of in different cases in 1.1, right? Where we had to solve out just by factoring. So, how do we factor this one? Well, yes. I'm going to take it back to just the pieces of figuring that out, though, right? So if we have 5, we know we have to factor that into what? The only way it can factor, right? It's a prime number. Has to be 1 and 5. Because x squared just has a 1 coefficient, then we just have to deal with 1 and 5, right? So the first kind of basic setup of the factorization is that we know x and x, and then we know 1 and 5. Because it's negative 5, we know the signs are opposite, different. And then because it's minus 4x, that means it has to be minus on the greater one, so the 5, and then a plus on the 1. Because if we have minus 5, we add 1 to get negative 4. Right? When you're setting up a factorization like this, the thing to check to see if you did the factorization correctly is just the outer inner multiplications. Right? You had to do this one correctly, right, to get the first, And then by doing this, we had to do the last correctly. Okay? If you want to just fully make sure, do out the full FOIL, right? But it's really just important to check the outer inner. Okay? So from this point, what do? We say that x plus 1 equals 0 and that x minus 5 equals 0, right? So, then we just solve, right? So we get x equals -1 and x equals +5. So, some formatting of how to enter it into the system, okay? They will take your solutions, right, and have the squiggle brackets, okay, around the answer box. I literally really don't know the real name of them. It doesn't matter what order you put them in. It's not specific. You can do -1, 5, 5, -1, doesn't matter. You just have to put a comma in between them. Okay? That's the kind of formatting. All right? Okay. So, that would just be kind of our final answer. All right? Okay, next. We're good with this now, right? Yeah, question?
So like, would that be called the AC method? Like, would be different names?
It's not the AC method. This is technically the guess and check. Even though I always thought it was a little bit more reliable. Not reliable. To me, it just made more sense than the AC method, usually. The factorization part is what you're asking for, right? Yeah, it's technically called the guess and check.
Like, that's the name for it?
Yeah, unfortunately. It has a bad name, right? But that's what it's been called, and it stuck. Okay? So, like I've said, if you know and like the AC method, that's perfectly fine to use it. Okay? Alright, so next we have x squared equals 4x. What now? What? We go home? Yeah, I mean, hey, that is technically an option, right? It's not necessarily the good option or the option that will solve the problem, but it is an option. Okay, so get it equal to 0. Yes, it still applies. It doesn't matter what terms we have. You always want to get it equal to 0. So, we subtract the 4x over. You always try to stay with a positive x squared term. It will literally make life a lot easier, okay? You do not want a negative x squared term if you can help it. So, x squared minus 4x is equal to 0. Now what? Factor out a common term, so in this case an x. We cannot do the same style of factorization because we don't have that plus c term, right? We don't have the constant. So in this case, when you have two terms like this, first always check for commonalities, okay? If there's nothing in common, see if it's a difference of squares, right? If there wasn't an x on that, then this would be a difference of squares, okay? All right, so now we factor out the x, and what do we get? X minus 4. When we factor variables, we go down a degree, right? It's like division. Factoring literally is just division. Okay? In process, at least, the inner part. All right, so from here, the factors don't look the same, but it's still two things being multiplied equals 0. So we still set it up the same way. We still do x equals 0 and x minus 4 equals 0. Okay? So then, this one's already solved. We just have to solve this one. So we just get x equals 4. Remember, right? 0 is not bad. 0 is a valid answer. Do not throw the 0 away, okay? Expect most of the time on quadratics to get 2 answers, right? Okay? Occasionally, we will get a double answer, okay? And then sometimes you don't get any answers. That would be where the kind of the quadratic is prime, right? It's not factorable, okay? But in those cases, we do have some things that we can do. We'll get to that in just a minute, though. So, if we had, what was the next one? Oh, just one quick thing to mention on this one. Do not actually divide by x. If we divided by x right here, from the very beginning, or here, right? It doesn't matter which step we're at. If we divided by x, we would end up with x equals 4. We would only have half of our answers. The program will mark it completely wrong, okay? So just make sure not to divide by your variable. That is technically invalid because in this case, it could have equaled 0. And, right, we can't divide by 0. So we just did something that is illegal kind of thing. Okay? Yeah?
When it's written like that, can you just like insinuate that one of the answers is 0?
When it's written like this,
Yeah, like
when both of your terms have x's, most likely, yeah. I mean, I want to say yes, but I'm sure we could come up with something where I would say yes and then it would be wrong. So I don't want to say 100% yes. Okay? For us, yes, though. I will go there and say yes for you. Okay? Any other questions? Okay, so then if we have one of the form 3x squared minus 12. So 3x squared minus 12 equals 0. It's not quite the same as last time, right? Because last time we had both terms had x's. So what should we look to do first? Look for the commonalities. Just because last time the commonality was an x doesn't mean we shouldn't look for number commonalities as well, right? So in this case, this is different from the x because the x was the variable. We can't get rid of the variable, right, by dividing it out. However, numbers, let's make it simpler. We don't need the number, right? Let's divide by 3. We're only doing this though because it's a number, not a variable, right? So, what do we get? X squared minus 4, because we divide both terms by 3. Remember, you gotta share, everybody gets divided. So then equals 0. What now?
Factor the difference of squares.
It's a difference of squares, so we can factor it. How do we set up a difference of squares factorization? X plus and x minus 2's, right? Okay. I prefer this method, okay? There is another method to factoring difference of squares. When you have it equal to a number, okay? Only a number. If there's a variable, you cannot use this method, kind of thing, okay? If you were to say that x squared equaled 4, you could then take the square root of both sides. However, this is a very like capital, bold, bigger text and everything. However, you have to remember to put, when you take the square root, plus and minus on the 4. Because remember, we should get 2 answers, right? So at this point, we know the square root of 4 is 2. We would get plus or minus 2. Okay? That gets forgotten a lot. So then you only get one answer, and then it marks it wrong completely. That is why I don't prefer that method. Okay? I would use this method. Okay? There are a few types of problems where this is like a shortcut. Okay? It makes the problem a little quicker, a little easier, but it is not the only way you can do it. Alright, so I'm going to put up another problem, and we'll do it both ways. So you can kind of see how it can make it a little quicker, but not difficult kind of thing, just quicker. So, if we have the quantity x minus 2 squared minus 36 equals 0. Okay? In this instance, even though it looks kind of weird, right, we still have a difference of squares because this quantity is squared and 36 is a square of 6, right? We can set this up that if we subtract the 36 over, we get x minus 2 squared equals 36. Take the square root of both sides, right? So then we would get plus minus square root of 36 equals, right, the square root of quantity x minus 2 squared. So now we simplify, right? So square root and square cancel. This side we're just left with x minus 2. This side we're left with plus minus 6. Now, separate, okay? X minus 2 equals positive 6, and x minus 2 equals negative 6. And then simplify, finish solving for x. So we get x equals 8, and x equals negative 4. Okay? We can see this didn't take that many steps, right? It was pretty quick, wasn't too bad, but there's a different way where we don't have to use that method or have to then remember to do the plus minus. If we go back to the beginning, what if we just spoiled this out, right? That is a perfectly valid method. So if we had x minus 2 times x minus 2 minus 36 equals 0, let's FOIL this. So first would be x squared, outer, inner, and then last is plus 4. Don't forget the minus 36 equals 0. Combine like terms, right? So we have x squared minus 4x, then minus 32 equals 0. Okay? Now it's just a regular old quadratic that we need to factor. Okay? Yeah? Yes. You're jumping ahead. I'm going to do that next problem. But yes. So, if we look at this, we should look at 32, right? So 32 can be factored in what way? Well, remember, start off with 1 and 32, and then does 2 go in? Yes. 32 is a whole bunch of 2's. So 2 and 16, and then not 3, 4 and 8, not 5, not 6, not 7, and then we're back to 8. So we did full circle, right? So those are our possible factors. Now, the 32 is negative, so that means we want a difference, right? First term is 1. We don't need to care about it. Let's just look at these differences. If we were to kind of look at just the difference in the two numbers, we would get 31, 14, and 4. Well, we want 4, so we should use the last 2, right? Does that make sense? We're still good? Okay. So we get x and 8 and x and 4. How do we decide the numbers? -4, so the negative goes on the bigger term. -8 plus 4. If we solve this, right, we get x minus 8 equals 0, x plus 4 equals 0. Solve, so x equals 8 and x equals -4. We got the same thing. There were definitely more steps here, right? However, you can't forget something on this way, right? You can't just not do one of the answers. Okay? So, if you feel comfortable that you're never going to forget the plus minus, go ahead, feel free, right? But this is always an option, okay? That's just like a shortcut, helpful way of doing it. Questions? No? Okay. So, I want to do two more things that we will have time for real quick. So, the next one that we want to factor is 2x squared plus 5x minus 3 equals 0. It's already equal to 0, so we don't have to do that. Is there anything that all 3 terms have in common? Nope, not at all. So, what do we do?
Quadratic function.
I'm gonna get there on the next one. We're gonna still try to factor this one. So, we want to look for the terms, right? The factors of first number and last number. They're both prime, so this is a little bit easier. There's not as many options. So do the first term, it's just 1 and 2, and the last term, just 1 and 3. We want to get to 5, but we want a difference, right, of 5, because the last term is negative. So to get a difference of 5, that means we need to get above 5 first to go back to it, right? What combination of these numbers would get us above 5? We would need to multiply the 2 and the 3 together. So if we want to multiply the 2 and the 3, that means they cannot go in the same parenthesis set, the same factor. Okay, so let's set it up first by the first numbers. So 2x squared can only be factored into 2x and 1x, right? You don't need to write the 1, but I'm just writing it for emphasis. We just said that we wanted to multiply the 2 and the 3 together. We do not multiply these two numbers, right? So if we put the 3 here, it won't work right. So that means we have to put the 3 here. Does that make sense? No? Why not here? Think about FOIL, right? So first we do these, outer we do these, inner these, and last these. These two never get multiplied. We wanted to multiply the 2 and the 3, so we can't put the 3 here. Whatever you multiply has to go in opposite factors, opposite parts. So 3 here, and then that means there has to be a 1 here. Okay, so what are the signs though now, right? We want to end up at +5. So we have to go up to +6 and then subtract 1, right? So these give me my 6, so we need +6 and -1. But check it, right? If you're not sure on the signs, guess and check. Now we see why it's called that, right? You can always just erase and try it the other way. Okay? However, any of these problems we can solve using the quadratic formula, as many of you have now mentioned. okay? But it's worth going through all these other methods just so that you can see and then be comfortable kind of with maybe what we're expecting when we ask you to specifically factor it or use a certain method, okay? Because remember what I said about going in and kind of fixing the problems that you got wrong on the quiz. If you go in to fix a problem and it says to solve by factoring and you use the quadratic equation to get it right, they're not gonna, they're gonna have you do it again, but by factoring, okay? Now, on a quiz or a test, I don't care, okay? That is only for if you have to then go back in to get points back, all right? Does that make sense, what I'm saying? On the time thing, do the method you're comfortable with. That's what matters, okay, is understanding the material. I would like you just to be familiar with all of these ways that we solve things today, okay? Now, before we all leave, let's just remember the quadratic equation. It is x equals negative b plus or minus the square root of b squared minus 4ac all over. I'm going to emphasize that again. All over. Not just divide this part or this part. All of it. By 2a. So, if I have 2 plus or minus 6 over 2, do not give me 1 plus or minus 6, right? That's not equal. You got to divide both by 2. So this does not equal that. It does equal 1 plus or minus 3. Okay? Remember, you got to share the division. Everybody wants part of it. Not really, but just the equation does. Okay? And remember, A, B, C. It would be worth writing those out, writing the formula, finding your A, finding your B, finding your C, and then just plugging in, okay? One more thing. Y'all preemptively pack up. Just one more thing. If you try to give the program an answer, something like square root of 50, it will tell you that's wrong, or a version of the right answer, okay? You have to fully simplify this. What you want to look for here, what are the factors of 50? 25 and 2, thank you. There's too many. So this is the square root of 2 and 25, right? We can break that up into two separate square roots. Square root of 2 and square root of 25. Square root of 2, can't do anything with it. Square root of 25, though, is 5. So, one other thing, just so that it doesn't get written weird and then you don't type it in oddly to the program and get it wrong. This integer, put it on the front so it doesn't get sucked into this quadratic square root, okay? So don't write it as square root of 2, 5, because literally I have seen this be long and then you think that's a square root of 25, okay? Just help yourself out and make it 5 square root of 2, okay? Does that make sense, how we did that?
Yep.
Yes? Okay. All right, so that is the end of this lesson.